Okay, this is video number 4 in the Math Excel Test 4-5 practice walkthrough. Number 15, if sine of theta is equal to 4/5. Now, let's just pause for a second and think about what that's saying. We don't know the angle measure in this particular problem, but we do know the y coordinate inside the unit circle is equal to 4/5 or 0.8. Now, none of the angle measures that we memorized in our unit circle had a y value of 0.8, but I do know that an angle measure here, this angle, whatever that is, would have a y value approximately of zero point 0.8. But so would this angle measure. So there are two positions inside the unit circle that would yield a y coordinate of 0.8. And so immediately we're being told that the angle theta, unknown angle here, does exist between 0 and pi over 2 radians. So that throws this angle out right away, and we're dealing exclusively with this one. So even though we don't know what angle theta is, we can actually answer a lot about that. Could we find the y coordinate of twice that angle? Could we find the x coordinate of twice the angle? Could we find the y coordinate of half of the angle, or the x coordinate of half the angle, tangent of half or twice? And the answer, of course, is yes, we can by using our double and half angle identities. But also, since we don't know the angle measure, we're going to need to think of sine, cosine, and tangent in terms of a right triangle. So let me try to recreate a right triangle that has approximately the same angle. So here's that theta value that we don't know. That's this angle here. What we do know is that sine is equal to 4/5. So now if we get out of the unit circle mindset and think of a right triangle mindset, this 4 is the opposite side length of a right triangle, and 5 is the hypotenuse of the right triangle. So opposite side length 4, hypotenuse 5. With just a little bit of math, we can establish that the adjacent side length is 3. Normally, I would use the Pythagorean equation to find this. A squared plus b squared equals c squared. But since this is a 3, 4, 5 triangle, I think that's easy enough to identify. Now, why would that be helpful? Well, let's remind ourselves of this. We have to go back to day 56 notes to see our double and half angle identities. But our double angle identity for sine was equal to 2 sine theta cosine theta. So when we're being asked to answer A, find sine of 2 theta, well, I need to say, well, that's going to be 2 times whatever sine theta times whatever cosine theta is. And we were already told that sine theta is equal to 4/5, so that part's easy. 2 times 4/5. But cosine of theta, that would be kind of difficult to find. However, we just established the right triangle associated with this angle measure. And since we've established the right triangle associated with this angle measure, finding cosine is just as easy as identifying the adjacent side length, dividing it by the hypotenuse. And we have 3/5 for that. And as we multiply across, 2 times 4 is 8 times 3 is 24. And divide that by 5 times 5 is 25. So the exact y value of twice the angle measure is 24/25. So again, I don't know where that's going to land in the unit circle, but by seeing this, 24/25 is almost 1. So I'm guessing that twice the angle measure is very, very close to vertical, either here or here. And I would probably, if I had to venture a guess, think that it's over here on the left-hand side. Some further discussion would be able to verify that. For the double angle of cosine, again, referring back to our notes from day 56, well, we've got 3 different forms of the cosine double angle identity. And any one of them would work just fine. So since sine was given to us, and that's the only thing that was given to us, cosine is technically a calculated value. Um, in the event that we had a decimal value instead of a nice fraction, I'd be leery about using this first or the third definition. So I'm going to use this second definition here, 1 minus 2 sine squared. So cosine of that double angle is 1 minus 2 times sine squared. 1 minus 2 times, well, sine we said was 4/5, so we must square that. And that leaves us with 1 minus 2 times, well, 4/5 squared is 16/25. Double that, and you've got 32/25. I'm thinking about the number 1 now as 25 over 25. And now we've got a common denominator that can be subtracted. 25 minus 32 is -7. And the denominator remains the same. So -7/25. For the half angle of sine, half angle identity for sine, we established those later in the lesson on day 56. And we have to be very careful here because the half angle identity for sine is either positive or negative depending on your situation. Now, since our angle measure back here was described as some angle between 0 and pi over 2 radians, then half of that angle, half of this angle, I don't know where it is, but somewhere in here, let's say, the y coordinate here is also going to be positive. The x coordinate in this region is going to be positive as well. So I don't need to worry about both positive and negative solutions. I'm only going to utilize the positive component of the half angle identity for sine. And so that looks like this, the positive square root of 1 minus cosine theta divided by 2. And here again, we've already established what cosine was by considering the right triangle associated with that angle. So we've got 1 minus 3/5 divided by 2. And I wonder, I haven't tried this, but I wonder if Math Excel would accept this answer. It's technically correct. It hasn't been simplified, but the instruction doesn't say to simplify. It just says produce an answer in radicals as needed. So I'd be willing to take a shot there because the additional work necessary to simplify this, well, we got to change 1 to 5/5 minus 3/5. All of that still is a fraction over 2 inside of a radical. So we're looking at 2/5 divided by 2. And this 2 technically divides this numerator of 2. Those are in the same position. Numerator will cancel, and we're now left with 1/5 over 1 over 1, which is the square root of 1/5. And now I'm curious. Yeah, even Math Excel doesn't like that as an answer either, although I'm perfectly happy with it. There's a thought in mathematics that you don't want to take the square root of a fraction either. We don't like square roots in the denominator. We don't like square roots of fractions. That's an easy fix, however. Square root of 1 divided by the square root of 5. Well, the square root of 1, of course, is 1, and we can rationalize the denominator from here to get the desired result that Math Excel is after. For the half angle of cosine, again, we're talking about a positive angle measure, so I'm just going to use the positive square root 1 plus cosine theta over 2. So that's going to look like 1 plus 3/5 over 2, which is 5/5 plus 3/5 over 2, 8/5 over 2. 4 divided by 2 is 4, so we're looking at the square root of 4/5. And again, if Math Excel doesn't like that, or if you'd like to take it further to simplify, you certainly could using the same process as before. Though again, I will say this, that if your math was correct, then Math Excel will accept that as an answer. And the two identities for tangent, the double and half angle identity, are shown here. again from day 56. For our double angle identity, 2 times tangent, which is opposite over adjacent, and in the denominator, again, opposite over adjacent, 4 over 3 squared, gives us the 16 over 9. And when simplified, finding the quotient of two fractions is the same as multiplying by the reciprocal, and simplifying along the way, we end up with negative 24/7. And by substituting 3/5 in place of cosine theta, we would simplify to an end result of 1/2. So that was a lengthy problem there, especially if you're not comfortable or familiar with the double and half angle identities. I'll go ahead and stop this video now and pick up with the next problems in the next video.